Hello, my dear students of class 11th. Today I am here just to tell you about how we calculate the capacitance of three different type of capacitors like parallel plate capacitor, spherical plate capacitor, and cylindrical plate capacitor. So I will start one by one. Number first is given PPC means parallel plate capacitor. Now look here. These are the two plates M and N. I have told you already that capacitor is an arrangement in which two plates are used. In these two plates, one plate is connected from the earth. In this way, two plates are here, M and N, in which plate M is given charge plus Q. So this is the charge arrangement over the plate M. Due to induction on the front side of this plate, minus charge will induce and the positive charge will travel towards the earth. D is the separation between the plate and A is the uniform area of the both plates. Means area of plate A is also A, capital A, and area of plate B is also capital A. You can see here D is separation between the plate and A is uniform plate area. We all know that electric field induced due to metal plate E is equals to sigma upon epsilon naught. In place of sigma, you can write Q upon A. So this term will become now E equals to Q by A upon epsilon naught, or you can write Q upon A epsilon naught. Now there is a potential difference between these two plates. Let the potential of this plate is Vm and potential of this plate is Vn. Here is Vm and here is Vn. So there is a relation between the intensity, potential difference and the separation. With the help of that relation you can write E equals to Vn minus Vn upon D. You know this formula, E equals to dV upon dr. So with the help of this formula you can write this way, is equals to Q upon A epsilon naught. Now Q upon Vm minus Vn, by transferring the term this side you will get A epsilon naught upon D. This Vm minus Vn can be write only V. So Q upon V equals to this much. Q upon V, we all know it is capacitance. So capacitance is equals to A epsilon naught upon D. So my dear student, this is the formula of capacitance of parallel plate capacitor. This formula indicates that capacitance varies directly to the plate area and capacitance varies inversely to the separation between the plates. There are two important points I have written here. Just try to look here. If plate area is different, in this derivation, both area is A. Suppose that this is A1, this is A2, then what we will do at that time? Then we use a small area for calculating capacitance. Means the value which we put here, we will find which area is small. That we will write in the formula and we will get the formula of capacitance. Number 2, here between the plate air is present. Suppose that any dielectric medium is present, then what the formula will be? Everything will be same, only we introduce dielectric constant here. Means the formula will be C equals to K, A epsilon naught upon D, where K is called dielectric constant. Okay. Now, number 2 is spherical plate capacitor. Look the figure. This is first sphere, this is second sphere. Second sphere outer surface is grounded, that is connected from the earth. Inner sphere is given charge plus Q. Charge resists itself on the surface of the sphere. Due to induction, here negative charge will locate. This sphere named is M, this is N. A is inner radius, B is outer radius, written here. Okay. We know this formula, E equals to minus dV upon dr. Shift dr this side, so you will get dV is minus dr. Integrating both sides, integral dV is minus integral E dr. You can see the potential initial is Vn and final is Vm, so we can put the limit here. Same for limit distance also, with the formula of intensity 1 upon 4 pi epsilon naught q by r square dr. Now V, Vm, Vn minus q upon 4 pi epsilon naught integration a v 1 upon r square dr. Now when you integrate you will get v. Now put the limit, final limit, initial limit Vn minus Vm minus q upon 4 pi epsilon naught as it is into integration of this you will get minus 1 by r. Everything is same. In the next step Vn minus Vm equals to q upon 4 pi epsilon naught minus, when you will come outside it will come plus 1 upon r a to b. Now put the limit here, final limit 1 upon b minus initial limit, then you will get 1 upon a. Because this is higher potential region, this is lower potential, that is why net potential will come with negative sign. So minus v equals to, and this is simple mathematics you can apply and you will get this bracket. Now v will be what? Minus will come inside, so this will be v minus a. Now q upon v you will get this formula, and q upon v is known as capacitance. So this is the formula of capacitance of spherical plate capacitor. Okay. Now the third one is cylindrical plate capacitor. Here it is one cylinder and this is another cylinder. From blue color outer cylinder, from black color inner cylinder. Inner cylinder is M, outer is N. Inner radius is R1, outer is R2. Charge plus Q is given to the inner cylinder. Charge has been located in this way. Due to induction, negative charge is produced, and outer surface is connected to the ground, so the positive charge will enter in the ground. Now the parameters are written. For cylinder we all know, we have already applied Gauss application. From there you will get E equals to lambda upon 2 pi epsilon naught into R. You know this formula. Integration dV is minus integration dr. Put the limits Vm, Vn, R1, R2. When you integrate this you will get V. After putting the limit you will get final limit minus initial limit equals to minus. In place of E you can put this relation. So lambda upon 2 pi epsilon naught will be outside because it is constant. Integration 1 by r dr and limit is r1. Now there you will get minus v minus lambda upon 2 epsilon naught as it is, and 1 by r dr integration is log r r1 to r2. Minus minus cancel out, v equals to same result. In the bracket put the values of limit, so log r2 minus log r1 to the exponential case. This can you write r2 upon r1 with log. So this is now lambda upon this much. Now v equals to, in place of lambda you can write q by l. So you will get this particular line. Now q upon v if you write, you will get 2 pi epsilon naught l upon log exponential base r2 upon r1, and q by v is what? C. This is the formula of capacitance. If you want to convert this exponential base in the base 10, multiply by 2.303, so your formula will be now C will be 2 pi epsilon naught L divided by 2.303 log base 10 bracket R2 upon R1. So my dear students, these three relations are very important. Capacitance for PPC, that is parallel plate capacitor, number 2 for spherical plate, and number 3 for cylindrical plate capacitor. With the help of these three formulae, you can calculate the amount of capacitance. Okay, all the best.